Have you ever stopped to think about the phone in your hand or the car you drive? These things are built by thousands of people in dozens of factories all over the world. So how can we possibly trust them to work? Well, the answer is this incredible 4,000-year story about an idea we call quality. Let's dive in and see how we got from a simple craftsman's promise to a global system. Okay, so it all starts in a much, much simpler world. A world where quality wasn't some department or a chart on a wall, it was a personal promise. But as things got bigger and faster, that promise started to break, leading to a real crisis. Just look at the difference. On one side, you've got the craftsman's world. Think of a master woodworker who feels the grain, sees every detail, and literally puts their personal mark on the finished piece. They own the quality. But then, the factory world comes along. The Industrial Revolution separated the worker from the thing they were making. All of a sudden, you've got massive volumes, which is great, but you also get these massive rework piles, literal monuments to a loss of quality. Now, even before factories, people had systems for this. You could call them the very first quality benchmarks. We're talking ancient Chinese artisans stamping their bronze work, or European guilds having their own special marks. This wasn't just branding. It was all about accountability. If something failed, you knew exactly whose reputation was on the line. It was a chain of trust, passed down from master to apprentice. Then, a new philosophy came along that just changed everything. Scientific management. You might know it as Taylorism. The idea was pretty simple. Separate the thinking from the doing. Management would design the perfect, most efficient process, and workers would just execute. And you know what? It worked. Production went through the roof. But there was this huge hidden cost. By turning workers into cogs in a machine, it basically stripped away their ownership, their connection to the quality of the final product. So this growing crisis, these piles of bad parts, unhappy customers, it really set the stage for a true revolution in thinking. People started to realize you can't just inspect for quality at the end of the line. You have to build it in from the very beginning. And the real game-changing idea came from a guy named Walter Shewhart at Bell Labs. He had this incredible insight. He realized that trying to sort the good parts from the bad ones was a losing battle. The real breakthrough was to stop looking at the parts themselves and start looking at the process that made them. Is the process stable? Is it predictable? This single idea changed everything. To make this real, Shewhart created a simple but absolutely brilliant framework, the Plan, Do, Check, Act cycle. It was the first real scientific closed-loop system for learning. So instead of just guessing, you could plan a change, do a small test, check the data to see what happened, and then act on what you learned. This little loop, it's basically the grandfather of every single modern method for continuous improvement. So after World War II, these ideas found a home in a really surprising place, post-war Japan. An American statistician, W. Edwards Deming, went over and started lecturing to Japanese engineers and CEOs. He taught them a simple lesson. Stop blaming the workers for problems. Instead, use data to understand and reduce the variation in your processes. And they listened. Their factories turned into these incredible laboratories for quality. And the movement just exploded from there. Pioneers like Joseph Juran and Kaoru Ishikawa created these simple visual tools, things like the fishbone diagram, which let teams on the factory floor easily figure out the root causes of a problem. They created quality circles, putting power directly into the hands of the people doing the work. Suddenly, quality wasn't just a job for some inspector. It was becoming everybody's job. All right, so you've got all these powerful tools and new ways of thinking. The next logical step was to bring them all together. They started to evolve from just a collection of good ideas into comprehensive global systems for managing quality. The 1980s were a massive wake-up call, especially for the West. Japan, which used to be known for cheap copies, was now making cars and electronics with absolutely stunning quality. There was this NBC documentary, If Japan Can, Why Can't We?, that sent total shockwaves through American boardrooms. This kicked off a race to adopt systematic approaches like Total Quality Management, or TQM. And it all led to the creation of ISO 9000, the first real global standard for how to run a quality system. Now, the really crucial thing to understand about ISO 9000 is that it wasn't about certifying a specific product. It was about certifying the process a company used. Basically, did you document what you do what you documented, and could you prove it? This created a common language of trust that allowed a company in Germany, say, to confidently buy parts from a supplier in Taiwan, knowing their systems were solid. So, this big push for systematic control for standards like ISO 9000, it really laid the groundwork for the modern era. It created a world where companies could go beyond just having a system and start truly perfecting it. And this is where two incredibly powerful data-driven philosophies came into play that pushed the limits of what anyone thought was possible. Those two paths were Lean and Six Sigma. You can kind of think of it like this. Lean, which grew out of Toyota, is obsessed with speed and flow. It's like a hunter constantly searching for and eliminating anything that doesn't add value, what it calls waste. Six Sigma, on the other hand, which was born at Motorola, is obsessed with precision and control. It hunts down and eliminates variation, because variation is the enemy of consistency. So one chases waste, the other chases variation. And the ambition of Six Sigma was just staggering. The goal wasn't to be 99% perfect. No, it was to be 99.999966% perfect. What does that even mean? It means just 3.4 defects for every million chances. Think about that. This wasn't about making things a little bit better. This was a quest for a level of perfection that was almost unimaginable. So how on earth do you get that precise? Well, at the heart of every Six Sigma project is this super rigorous 5-step method, DMIC. You define the problem with incredible clarity. You measure all the key parts of the process. You analyze the data to find the true root cause. You improve the process based on what that data tells you. And finally, you control it to make sure the problem never comes back. It's a highly disciplined, data-first approach to problem solving. Over time, smart companies realized they didn't have to choose between Lean and Six Sigma. They could merge the speed of Lean with the precision of Six Sigma. And today, that powerful combo is being supercharged by technology. We're talking AI that can predict failures before they happen, IoT sensors that give us real-time feedback, and new standards that are all about thinking proactively about risk. So, after this amazing 4,000-year journey, from a simple mark on a piece of pottery to AI-driven factories, you have to ask, where does quality go from here? What is the next great leap forward? You can really map this whole story across 3 big shifts in mindset. First, we were reactive. We had an inspection mindset where we just tried to sort the good stuff from the bad stuff at the end. Then, we became proactive. We used tools like control charts to prevent problems and build quality in from the start. And now? Well, now we're entering a predictive era. We're learning to anticipate, using AI and real-time data to forecast and stop issues before they even exist. Through this entire evolution, a few core lessons have really stood the test of time. Quality has to start way back in the design phase. The people actually doing the work have to be empowered to control it. You have to use data to understand the process, not to blame people. Your quality is only as good as your suppliers. And, maybe most important of all, you have to build in these constant loops for learning and getting better. And that brings us right to the edge of the next frontier. The great quests of the last century were about getting to 0 defects and 0 waste. I mean, those were incredible goals. But what's next? As our systems get smarter and more connected, maybe the very definition of quality needs to expand again. So the question is the future of quality really about achieving 0 harm? A world where our products not only work perfectly, but also keep people safe, protect our environment, and consider our total impact on the planet? That's the challenge for the next generation.